Vehicle-to-grid enables solar EVs to store and return power, stabilizing the grid, lowering costs, and enhancing energy resilience. What is a vehicle to the grid? During the day, solar panels charge electric vehicles with clean energy. When parked, electric vehicles store the extra power, turning into mobile batteries. At night, they send energy back to the grid, helping balance the system. This is vehicle-to-grid, a seamless, two-way flow of energy between EVs and the grid. Let's see, how does it work? Electric vehicles charge by absorbing excess solar energy during peak production times. Then, during periods of high demand, they discharge, feeding energy back into the grid. All of this is managed through smart control systems using vehicle-to-grid inverters and advanced communication protocols. Electric vehicle infrastructure is powered by advanced, smart technologies designed for a seamless and future-ready energy ecosystem. Bidirectional chargers, both AC and DC, enable two-way energy flow, allowing vehicles not just to charge, but also discharge power back to the grid or home. Smart metering systems provide real-time energy tracking, dynamic pricing, and accurate billing for both users and utilities. Grid synchronization controllers ensure safe and stable integration with the power grid by matching voltage, frequency, and phase. Energy management systems, which intelligently optimize energy usage, balance loads, and help reduce operational costs. For effective communication and control, our systems adopt global standards are ISO 15118 for seamless vehicle-to-grid interactions, OCPP for universal charger communication, and IEC 61850 for integration with substation and energy networks. Together, these technologies enable a robust, smart, and sustainable EV charging ecosystem. Vehicle-to-grid faces several regulatory and integration challenges. Grid compatibility is critical, ensuring safe and stable connections despite varying utility standards. Battery wear must be managed carefully, as frequent charge and discharge cycles can accelerate degradation. Energy ownership raises important questions about who controls the stored energy: the driver, the utility, or an aggregator. And compensation models need to evolve, with dynamic tariffs and incentives that fairly reward energy exported back to the grid. Let's see about grid stabilization. It's all about keeping the power system balanced, especially when demand suddenly spikes. Then there's peak shaving. Reducing the load during those busy times helps ease the pressure on the grid. Frequency and voltage help keep the power stable and consistent, so lights don't flicker and systems run smoothly. And when the power goes out, emergency backup kicks in, giving you the energy you need when you need it most. With more renewables like solar and wind, energy storage lets us keep that clean power available, even when the weather changes. It also brings cost savings. By storing and selling energy back to the grid, you can lower your bills. Plus, it helps avoid the need for building new infrastructure, so reduced expansion costs for the grid. And, of course, there's the environmental impact. Using stored clean energy means fewer emissions and a smaller carbon footprint. At Green, we drive sustainability with innovative energy solutions. We empower progress, accelerate growth, and elevate lives.